So you've worked out how to overlay a sprite over an image using a colour key. So what happens if the sprite already has transparency defined? Let's find out. So I've got this Sprite sheet here. Now this one has this adventurer running along and it has transparency defined all around where we want to have it see through. So what I've done here is I've used the background that was defined in the previous video to draw that background of the jungle here. I've used another sprite that came with that same pack just to do the jungle floor, so I've created some sprites for that. And then I've got the main adventurer sprite, which is that animated sprite. I've made sure I've used the right image here, and I have used Sprite Sheet, which we spoke about in the Sprite Sheet video. I just made sure that I've got the right number of columns and rows here, which to match what was in that file. There were 8 across and 2 down. So what happens when I run this file? So it draws the jungle, but there is this black outline. It's not making any transparent pixels. Now, obviously, let's just check we've made the color key pixel, which is what we did in the previous video, and that is missing. But what happens when we set that? So image.setColorKey to set to black, because that is the black background we want to make transparent. And now when we run that, we see that it's sort of working, but there's something not quite right if you look closely. What seems to be happening is that, let's just run that again, the outline and the shadows, they have all become transparent. They're meant to actually be black. So this isn't the right way to do it. You want to use those transparent pixels which were in the original file. So this isn't the right way to do it. So what is the right solution? So if we look at the original image, we can see there are these black pixels here which we want to retain, and here is that transparency, which is what we're going to actually use to define the transparency on the final image. Now what we're going to do is we're going to actually have to rewrite how Sprite Sheet works, because Sprite Sheet doesn't allow us to do this. So, but actually it's not that complicated what it's doing. What we're going to do is we're going to take each one of these frames, and that's defined by the total number of frames going across here. So this is how Sprite Sheet does it. So you're dividing, so we have 1, 2, 3, 4, 5, 6, 7, and then one more if we scroll, 8. So we take 1/8 of the width, and that gives us the width of this box. And there are 2 rows, so 1/2 of the height of this image, and that gives us the size of that box. That's what we're going to calculate. And the first one starts at 0, 0, and then we're going to move across gradually, add 1 width across, and then another width across, and pick these out one at a time and put them into a list. Okay, so now we're going to write our own Sprite Sheet. How do we do the code for that? So I've got the bare bones of what this class is going to do. It's going to be called Sprite Sheet, and it is going to load the file up in the initialization phase, and it's going to have a method which is to get an image by index. So if I say get me image 3, it'll get the 3rd image along. And I need a method which builds that up into a film strip for us, which is essentially just a list of images, and we're going to be able to specify where we want to start within that Sprite Sheet and how many images are going to be in that film strip. So let's start off with loading the file. So we've been given a file name as a parameter there, so what we're going to do is load up that sheet. It's just the image using Pygame image, load file name. So that's just loaded that file. We haven't done any manipulating on it yet. And PyCharm is telling us that's spelled wrong. There we go. Now, and think I want to call it sprite underscore sheet, just a little bit more readable. Let's work out what the tile width is. And we can work that out from the number of columns and rows. So we need to know what is the total width of that image. So the way we do that is self.spritesheet.getWidth, and then all we have to do is divide that by the number of columns. Now we're going to do the same thing for the height. So it's now tile height, and it's going to be get height, and it's going to be the number of rows. And let's store those number of rows and columns. And the total number of images within that sprite sheet, let's store that as well. That might be useful, the length, and that is just equal to columns times rows. So that's the initialization, just loading up that sprite sheet. Now when we want to get an image by index, well, what we're going to do is use a method called subsurface, which is a method on the image, Pygame image. So our Pygame image is called self.spritesheet, self.spritesheet. And what we need to do is call get, no it's not get, it's just called subsurface. So what this is going to do is, we've got that sprite sheet is a surface, and we want to get a partial fraction of that surface. What will happen is that Pygame will therefore retain that transparency, which is what this problem is all about. We're losing that transparency. So when it loads the file, it'll know that that's got transparency, it'll apply that automatically, and when we pull out a subsurface, it'll retain that. So this is the right sort of method we want. Now the parameters you need to get this to work, the first parameter is in fact it's only got one parameter, which has got 4 parts to it. The x, the y, the width, which in our case is just we've already worked that out, self.tilewidth, and then the height. So what we haven't got is the x and y, so that's the position within the image. So we're going to have to work that out from what we've got here, which is n, so the number, the index within that. So let's call the y index ny. So we get n, and we divide that, a bit of maths here, by the number of columns. And the number, this is the number of images there are in the y direction that we're going to be picking out of that. So, and then ny is n modulo, so of course. And the number of the actual pixel position, therefore, is the number of images across times the size of a single tile, the width of a single tile, and the same for the y direction. So we've gone down ny tiles, and each tile is worth tile height, number of pixels. So that gets you the pixel position. So that there should get us an image by index. Now we just need to implement putting together a film strip, which we'll call get image by index. So we're gonna provide, so we're using a default value of length is none. So if you miss out, you don't have to provide this length parameter. If you don't provide it, we're just going to use every image in the sprite sheet. So that's a special case. Let's just deal with that first. So if length is none, then let length equals self dot length. We previously worked out up here the number of tiles on a particular image. And what we just need to return here is a new list, and what we're going to do is we're going to call the method we just wrote, get image by index I for I in range. I'm going to go from the value we requested here, start, and we're going to keep going until we get to start plus length. So that now should be our working sprite sheet. Now we're just going to make sure we use that within our sprite class here for the adventurer. So previously we were using the package that we imported, Sprite Sheet. We want to use our own Sprite Sheet up here now. So this is going to be slightly different. So we don't need to do any of this film strip stuff. In fact, what we're going to do is just delete that. We still need a film strip, but what we do is we get this now directly from our Sprite Sheet, and we need to call the method film strip. Now in this case, 8,2, that's right. Film strip, we want to start at image 1 and we want to get 8 images into our film strip. So let's see if that actually works. Right, so we've got a bug there, none-type object get rect. So when you have this sort of error in Python, none-type object, typically that means you've forgotten to put a return value in, because if you do leave that out, it will just return none. So the two candidates for that are where we return the film strip. Now we did remember to do that. And the other one was where the film strip was built up by calling get image by index. And here it is, and in fact, yes, there we go, it's not actually returning anything. So we actually want to return that subsurface. Now let's see if that works this time. And there we've got our animated image, and it's running along quite nicely. Proper transparency on that image.